Hey everyone, welcome to class. In this lecture, we're going to be focusing on measures of centrality and spread. This is continuing our conversation on from the importance of descriptive statistics and why we need them, and into our framework of moving beyond this sort of hypothesis generating and research question generating end of the design process and moving into actually analyzing some of our data and showing how we can start to convey it. So the agenda, right? So I really want you guys to think about the number or not caveat to start. This is going to frame the whole conversation. And what I mean by that is we're starting with this understanding that the kinds of measures of centrality and spread we can use are dependent on the level of measurement that we have, right? We already kind of alluded to the fact that if you have an interval ratio, you've got some really awesome detailed measures of central tendency that you can use. Interval ratio is definitely the most powerful. You can use the mean or the median. But if you're in the kind of world of nominal ordinal, you need to be using mode and range for centrality and spread. And so we need to start with first framing the sorts of kind of level of measurement we have, and then moving on from there. I'm going to kind of motivate why we need to care about centrality and spread a bit more. And then in this lecture, we're going to do how to calculate the mean. And then in the next one, I'll show you how to do the variance and the standard deviation. We'll start with measures of centrality in this one, and then move on to measures of spread later. So why do we need measures of central tendency? Let's motivate this one more time. It gives you a simple understanding of the way your data looks. It gives you a single number to describe that column or that variable. So it gives you a way to kind of efficiently state what's happening in your data. A really concise way to think about it is it's one number that best describes that whole column. So then why do we need spread? It helps us understand whether our measure of central tendency is a good one and whether it's accurately describing our data or how much our data deviates from that measure of central tendency. So we need both to really kind of understand what's going on in our data. And you can do this mathematically or visually through graphs. I'm going to kind of prompt you a bit more visually through the graph here in a second, and then I'll show you mathematically how to calculate these things. So we're going to start with a simple exercise. Where is the center? You can take a second to pause if you'd like here, or you can kind of just roll with me. So it's very clear probably to you where the center is. So our x-axis, we have a range of 50 to 100. And on the y-axis, we have frequency of observations or respondents. So this is a histogram. And we can then sort of interrogate where the bulk of our data lies, right? Where is the center of our data? Where are the bulk of the respondents or events? Well, it looks like they're between 70 and 80. Why do we feel that way? Because it's pretty obvious that the highest peaks or the highest bars kind of happen within those bins. And so it becomes pretty clear that that's where our measure of central tendency probably will fall. We also can see that the spread is pretty even on both sides, right? So that measure of central tendency is pretty accurate, probably, based on the spread. So we can look at both understandings of center and spread in a kind of distribution of our data like this. But what about this case? I'll give you a second to pause and think about it. So where's the center here? Well, we can make an argument for the center being just about anywhere. And so we really need to think about maybe both using measures of central tendency mathematically and visualizing our data to kind of get a holistic picture of what's happening. So in this case, it'd be really obvious if you got a measure of central tendency and then you looked at something like the range or the variance, it would be very clear that the spread is kind of wonky on this one, right? That all the bars are kind of the same and it's much less intuitive to understand what central tendency is. And so that number of central tendency will be less informative in this case than it will in the picture on the left, because the picture on the left, the spread is different, right? And so I want you guys to be thinking about this moving forward, and that we're going to be calculating these things mathematically. And it's going to look a little bit intimidating at first because I'm going to throw a little bit of mathematical notation at you, but you should feel pretty confident. It's very straightforward once you get going. But we also will want to be thinking about how to combine this with visualizations later on to really get a holistic picture of what's happening. So let's start with measures of center, and we're going to start with the mean. So the formula for our mean is featured here over to the right, and it's just the traditional average. I guarantee you've calculated an average at this point, coming up to your academic career at this moment at Cal Poly Pomona. You've definitely calculated an average before. You maybe not have seen the formula, but let's just get right into it. All you're going to do is add up all the numbers in the set and divide by the total number of units. So in this case, the formula shows that the mean is equal to the sum of all of our different parts. So sum is the sigma, this kind of crazy looking E thing. The N is the amount of features that we have, and then I just shows all the different observations. So this sigma N and then the I equals the E is just telling you that you need to sum across all the observations of X, right? So this is our big X over here on the right. So we need to sum across all our observations of X. It looks crazy, but when you put it in that term, it makes a little bit more sense, right? So once we have the sum of all of our different X's or our different observations, then we're going to just divide by the total number of observations. So let's do a couple examples. So I want you guys to pause at each point after I kind of rattle off the numbers and try to calculate it yourselves. So example 1, you're going to add up 3 plus 5 plus 5 plus 6 plus 7, and then you're going to divide by 5, and then you're going to get the average. So go ahead and pause for a second and do that. You should get 5.2. Super simple. Our average is very well indicated of the actual spread. It does kind of seem like the true center, right? The range, if we just wanted to kind of take a easy stab at it, the lowest number is 3, the top number is 7, so we have a range of 4. 5.2 is pretty plausible being a measure of center. We really love using the mean most of the time. The mean tends to be sort of the bulk and one of our powerhouses in stats. However, the mean is particularly sensitive to outliers or numbers that are far away from the rest of the set. So I want you to do the same thing with this next set. So there's the same amount of numbers, but one number is really different. So you're going to add up 3, 5, 5, 6, and 78 and divide by 5, and then tell me what you get. Pause here. In this case, you're going to get 19.4. Now, this is really interesting, right? Because the majority of our set stayed the same. 3, 5, 5, 6, all of that stuff looks the same. But the only difference is instead of having 7, we have 78. Because we're adding up and dividing across all of these values, it's much more sensitive to outliers. So an outlier is going to drag that average up towards the outlier, right? So it's going to raise it because that outlier was way higher, right? And make it a little bit less of a good indication of centrality for that set. So if we know we have a set that has a really strong presence of outliers that maybe aren't good indications of the rest of the set, we might want to do something like the median, okay? So the median is just the middle number. There's no fancy formula here. You're literally just going to line up the number sequentially, so smallest to biggest, and then cross out the lowest and highest one at the same time. Super easy. You're going to repeat till there's only 1 or 2 numbers left. If there's 1 number left, that's your median. If there's 2, you just take the average of them. So if we do this for example 1, you're going to cross out 3 and 7. You're going to cross out 5 and 6. Pause, decide what you think it is. It's just 5. Easy peasy, right? So the median is really easy to calculate, and it also is much more resistant to outliers because there's no sort of addition and averaging happening there. It's maybe sometimes less informative. It's not as commonly used, but it is more robust to outliers. So there's going to be certain cases where we find that it's much more helpful. So sometimes in the case of median household income, where there's really, really high ones that can pull it out away, and make the average a little bit less informative, they might be using the median, right? So median household income instead of average household income. Things to think about. So I'm going to do this with you guys one more time so you guys can see how powerful it is. You're going to do the same thing with the median here. You're going to calculate the median with the same set. Go ahead and pause, find it. you're going to see that it's still 5, right? Instead of with the average, it got yanked up and is 19.4. The median stays the same. So that is a huge benefit to having, to calculating the median instead of using the mean. Sometimes also we'll calculate the mode, right? This is much more common for, right, these ordinal or nominal variables, but we can calculate the mode as well for numbers. And you're just finding out the most common one, the most commonly occurring category. So go ahead and try and do it for the first set. Go ahead and pause here. Find out the most common number. It's 5, right? Because there's 2 5s in the set and every other one is an original individual number. And then in the second set, pause and find it. It's also just much more clear that it's just 5 in this case, right? Because we have so many more 5s occurring. So these are 3 different ways to calculate measures of centrality. The appropriateness of each of these depends on the level of measurement you have and the spread sometimes of the data and the presence of outliers. When I say spread of the data, I kind of mean outliers because the mean is going to be very susceptible to being changed by these extreme values. And sometimes we don't want that. Sometimes we want to understand things in context of the median, something like, again, like I mentioned, like household income, it's going to make more sense to do median instead of mean, right? Because we want to be a little bit more robust to outliers. The mode, again, we're probably not going to be using this one so often, but we will be using it in the context of our ordinal and our nominal variables.